Good morning, mathematicians. Today we are going to be exploring our knowledge of exponential functions and relating them to linear functions or linear models. So these two tables below, I have two different functions represented. One of them is a linear function and one of them is an exponential function. That's what I'm telling you in the do now. I want you guys or us to figure out which one is which. And we're actually going to form the equations for both of them at the very end, and we're going to explain how we know which one is which. So I already have the tables copied on my whiteboard here. I'm specifically just going to focus in, actually before we even look at the tables, let's take a time out and review. It's saying one is linear and one is an exponential function. So since that's the case, let's do a generic review on both of them. So linear functions. Let's talk about what we know about linear functions in general. So if I said to you, what do you know about linear functions? Let's start listing off some things. So if I was to call on Maya, she would tell me that the formula is y equals mx plus b. Always pops right into everyone's head. Now we can go ahead and break down okay, what do certain values mean? So when I say this m value here, Mario can tell us that that represents our slope. And we know that it's a constant rate. So when I'm saying a constant rate, that means that it's either increasing or decreasing by the same number for all of your values. When I say my b value, well, Brittany would tell us that our b value is representing our y-intercept, or our initial value, however you want to think about it. So that's my standard form of a linear function. Those are the key features of it, a little bit of a refresher. Let's talk about exponential functions, which is our new one. So if I'm talking about exponential functions, we have a standard form of our equation, which would be y equals a times b raised to the x. So I know this is an exponential function if I was to ask you that. Ashley would tell us because I have my highest power there, it's raised to the x. So I don't have a number there. My variable is actually my exponent. So that's how I know that that is an exponential function. So now it comes down to, what does a represent? So Ricardo would tell us that our a represents our y-intercept. Okay. And my b value, where I have my b there, that's representing our base. But we need to think about, for exponential functions, how do your values actually increase or decrease? So if your values were increasing, then I know Melissa would tell us that they're increasing by multiplication. And if they were decreasing, Lale would tell us the opposite, which means that it is by division. So your values for exponential functions, they grow and decay by either multiplication if they're growing, and decay if it's represented by division. And decay is another word for decrease. When I'm looking at my linear functions, they also increase and decrease. We know that. But linear functions have that constant rate, which means that they're increasing or decreasing by addition or subtraction. Okay, that's how your values are changing. They're either increasing by adding the same number and decreasing by subtracting the same number. So let's just focus in on table 1 here. So I have my x values in my top row and my y values in my bottom row. And I want to figure out, is it linear or is it exponential? So how do we go about doing that? Well, I know, let's just only deal with what we have here. I know that my x values here are going up by 1. Okay? So that does nothing for me. That's just a good, helpful hint. That means that my numbers are consecutive, which means that it should be easy to recognize a pattern. I really want to focus in on my y values here. So if I was to ask, Noelle, how are my y values here changing? We kind of have two options to play around with, since I'm guessing if it's linear or exponential. I know they're increasing, so that means I'm either adding the same number or I'm multiplying, since my numbers are going up. So let's say you're not sure. Well, if it's a linear function, we know that it has that constant rate, which means that every single time I should be adding the same value. So I have 5. If I add 5, that gives me 10. If I add 5, that does not give me 20. Right then and there, since I don't have that consecutive pattern of plus 5, that means that this function cannot be linear. Okay, so I don't have a linear function there. So now let's test exponential. We said that they must be increasing by multiplying. So 5 times what is going to give me 10? If you're not sure, always work backwards. So you should be saying times 2. 5 times 2 gives me 10. 10 times 2, oh, that also gives me 20. Perfect. 20 times 2, oh, that also gives me 40. 40 times 2 also gives me 80. So notice here, you have that constant base there. So that means that table 1 is an exponential function. And I know that it's an exponential function, table 1, sorry, because I have my values changing by multiplication. So now let's write the equation here. I know that that needs to be in the format of y equals a times b raised to the x. So now it comes down to, we know that my y-intercept is a, representing a. So on this table here, what is my y-intercept? And if I look at my table there, I know that my y-intercept, Sam would tell us, it's always when x is equal to 0. So my y-intercept is going to be that 0.05. And my y-intercept is my y value. So I have 5 substituted in for a. My b value, we just did all of the work. My b value there is times 2 every single time. So I'm just substituting in 2 for my base. And then I know it's an exponential function, which means my power needs to stay as x. And that's your equation. You can, even if you're not confident, you can always check your answer here to make sure that that's absolutely correct. So in order to check my answer here, Irvin would tell us we can substitute in different x values. So if I said like, oh, let's find f of 1, I would have 5 times 2 raised to the first. Well, 2 raised to the first is going to give me 2. 5 times 2 is going to give me 10. So that leaves me with the ordered pair 1, 10. My table of values, 1, 10. Perfect. If I change this to a 2, well, 2 squared is going to give me 4. 5 times 4 is going to give me 20. So now my ordered pair is 2, 20. Again, matches right there. So you know that you're good to go. So that's my exponential functions here. Looking at my second table here. So I want to know what type of function it has. Maybe I have 2 exponential functions given to you guys in your do now. Let's see. So I have 8, and then it went to 11. Then it went to 14. Then it went to 17. Then it went to 20. Okay, so my values are increasing, which means, again, they're either changing by multiplication or addition, because that's the only way they can increase. Well, this should be a straightforward, if you're not sure, like, okay, what can I multiply 8 by to get 11? You should probably be thinking some sort of decimal. Well, you can always work backwards. 11 divided by 8. Okay, so that's the decimal that's representing my base. If I multiply 11 times 1.75, notice it gives me 15. That does not give me 14. So this cannot be an exponential function. So that means it's linear. Well, I know that 8 plus 3 is going to give me 11. I also know that 11 plus 3 is going to give me 14. 14 plus 3, also 17. Every single time I keep adding 3, my pattern's continuing. I can even keep going then. If I add 3 to 20, that means that my next point is going to be 523. Like, you guys know what you're doing here. Okay, so I have a linear function. So B, table 2 is linear, which means I'm following my equation y equals mx plus b. Well, same thing. We just talked about that before. My b value, that's representing my y-intercept. So if I'm looking at my table of values here, I want to know, where do I see x is equal to 0? Right there. So my y-intercept in this case is 8. So I can go ahead and plug that in for B. M represents my slope. So looking at my table, again, you guys have all the work done for you. You already figured out that it has that constant rate of +3 every single time. So since that's the case, that just told you that your m value is 3. And you're just substituting that in. Y equals 3x plus 8. And that's your equation there. Same thing as before, you can always test this. If I wanted to evaluate it, like let's say f of 1, we'll plug in 1 for x. I would have 3 times 1 plus 8. 3 times 1 is going to give me 3 plus 8. That gives me 11. So 1 comma 11. Ah, Jessica, notice they're the same exact thing there. Perfect. That's how you know that your answer is correct. Right? So we just went through the whole do now together, and this is the entire lesson here. So I give you 4 examples that I will be grading you guys on. I want you to tell me what type of function it is, linear or exponential, and then I want you to write the equation for it. Okay? Have fun. I will schedule a Google Hangout for Wednesday, and enjoy.